you are sick and tired of doing the long limit formula as h goes to 0 to find the derivative of a function? I know I was. Did you know that there are secrets and shortcuts and tips that I can teach you today so you don't have to do that long formula anymore? Well, come on, watch the video and I will teach you 4 techniques for you to solve derivatives the easy way. Today I'm going to give you 4 techniques in solving problems that are asking you to find the derivative. How many of you really don't like to use the limit as h goes to 0 equation to find a derivative? It seems monotonous, it takes a long time, and how would you like to find out that there's actually a trick to solving these faster? That you don't actually have to use that long equation and plug in all of your functions to find the derivative. Right? Mind-blowing. So today I'm going to teach you 4 of those techniques to help you solve derivative problems. The first one is going to be the power rule, and I'm going to show you how this works. So make sure you get out a piece of paper. This is key. Write this stuff down on a piece of paper you won't lose. Maybe it's another color. It's maybe not in your notebook, but something that you can keep close readily by, so when you're solving these problems, you have these techniques written down. The first one is the power rule. It says this: when you take the derivative of x to some power, that power is going to come out front, and then you're going to subtract 1 from that power. So let me show you how this works in this example. If I want the derivative, d over dx just means find the derivative of this function. So the derivative of x squared is what we're looking at. So according to this rule, my exponent actually shows up down front. I leave my x and I subtract 1. So 2 minus 1 is just 1. And we don't write that 1, right? We don't see it. So the derivative of x squared is just 2x. Your mind just went, poof. You're thinking about all those long equations you used to write out and you're thinking, that's all I had to do? That's all you had to do. Wait till you see the next one. Now let's talk about the derivative of a constant. We already know how it works with the x, the variable, and the exponent. Let me show you how that would work with a number. So the derivative of our x squared, that 2 is going to come down front. You're going to subtract 2 minus 1, so it's just 2x. Plus, now what do we do with this guy? That 2 doesn't have a variable. Or does he? Technically, this guy is 2x to the 0. Oh, right? So what happens to that exponent? The 2 would come down. The 2 just comes straight down. Your exponent comes down in front. This becomes multiplied by 0. And then you have x, 0 minus 1 is to the negative 1. But hopefully you guys are all fixated on this guy right there. That's 0. Because what happens? That whole thing just drops out. 0, it goes away. So the derivative of a constant is just 0. It's nothing. So this answer right here would just be 2x. Now, of course, unfortunately, all your problems are not going to be that easy. So we need to look into something called the product rule. This is rule number 3. And I'm going to show you what it looks like right here. The product rule states that you take f prime. Remember, prime means you want the derivative. So f prime times g plus f g prime. That is the product rule. F prime times g plus f g prime. So the first thing you're going to do when you have a function is label each set of parentheses as either f or g. So I'm going to label this guy as f and this guy as g. What I'm going to do in a thought bubble is I'm going to put their derivatives down below to make it easy for myself. So f prime is going to equal, using my power rule, 2x. And then g prime over here is going to equal, bring my power out front, 3x, subtract a power, squared, plus 2x. Now that I have my fg labeled and my f prime and g prime labeled, all I have to do is plug it into the equation. Y prime equals f prime g plus fg prime. So my f prime here was 2x, and my g, I'm just copying it as it is, x cubed plus x squared, plus my f function, x squared plus 2 times g prime, 3x squared plus 2x. After this, you're just doing algebra. So now we're going to factor. Y prime equals 2x to the fourth plus 2x cubed plus, now we have to factor this mess on the right-hand side, x squared times 3x. So we've got 3x to the fourth plus 2x to the third plus 6x squared plus 4x. This is where you can start to combine like terms. So I've got a cube here and a cube here. I have to the fourth here and to the fourth here. And that's basically all you can narrow down. But sometimes it's nice to put lines or different colors or circle the terms that go together to make it easier for you to see and recognize. So y prime equals, we have 5x to the fourth plus 4x cubed plus 6x squared plus 4x. Here is your derivative. Now, you have to also remember that if they want the derivative at a certain x value, you take this equation and just plug in your x value to find that derivative. And remember, y prime is one way to write the derivative. It might also be written as f prime of x. Those are the same thing, or we also talked about it written as d over dx. Those are all forms of the derivative. I have one more rule to share with you. It's the quotient rule. This is when you have a function that is a fraction. So we're going to use low d high minus high d low all over low low. And you're like, she's nuts. But trust me, it works. Let me show you how this works. In the numerator, to find the derivative of a fraction, you're going to take f prime times g minus f g prime all over g squared. That's a lot to remember. But low d high minus high d low all over low low just seems to like roll off the tongue, does it not? Okay, maybe not, but it will stick in your brain and you will remember. And let me show you why this works. When you have a function that is f over g, your f is your numerator. This is your high piece. Your g is your denominator. That is your low piece because it's on the bottom, right? High is on top, low is on bottom. So watch what we do here. The quotient rule says you need to have f prime. D high stands for derivative of the high. F prime means derivative of f. F is your high piece, right? So derivative of the high times the low piece, your bottom piece. Now, does it matter over here that f prime is written first and then g? And over there we say low piece first? No, because it's multiplication. Doesn't matter which order they're written in. So, this is your low d high minus, now you have your high piece, which is f. So here's your high piece. Now I want you to multiply by d low, the derivative of your low piece. That's what G prime stands for. So do we all see how high D low minus low D high minus high D low all fits together? And look then at the bottom. At the bottom, they want G squared. That's how you get low, low. Low times low is low squared. G squared. Are we following? So, I would recommend that you write down the rule. I would also recommend that you write down low D high minus high D low all over low, low. Now let's try an example to see how this works. The first thing I would do is identify your F and your G parts. Right, here's your F, here's your G. Again, the other thing I would do is find the derivative and put them in thought bubbles so you can easily just grab them. So for your numerator, your F prime would be 6x, right? The 2 comes down front, 3 times 2, and then you subtract a power. Your G prime, your power on this x is just a 1. That 1 comes down, then you subtract 1 minus 1 is 0. So G prime is just 1. How easy is that? All right, so we're going to do low D high minus high D low all over low, low. So y prime equals low D high minus high D low all over low, low. Now I'm going to plug it in. My low piece is x plus 2 times the derivative of my high piece, 6x, minus my high piece, 3x squared, times the derivative of my low piece, which is 1, all over x plus 2 squared. At this point, we're just going to multiply out the numerator. So y prime equals 6x squared plus 12x minus 3x squared all over x plus 2 squared. I can combine like terms, and hopefully you're seeing we've got a 6x squared here and a minus 3x squared over here. So that will give us 3x squared plus 12x all over x plus 2 squared. You could probably leave your answer like that. You may want to check with the teacher or the textbook to see how they want their answer written, or if at this point you need to plug in an x value, you can do that at this point. Let's try a couple of examples. In this problem, we do not need to use the product rule because the 1/3 out front does not have a variable with it. We can just leave the 1/3 out front and then use the other rules to find the derivative inside the parentheses, then we'll multiply through. Y prime equals negative 1/3 7x to the 6th plus 2. And then this 1 minus 0, that guy drops out, and the 9 drops out because it's a consonant. So we're left with negative 7 over 3 x to the 6th minus 2 over 3. So this is your answer. Let's try another one that might be a little bit more tricky. If you don't remember, the square root of x really has a 2 in here for the square root and a 1 on that x. So this piece right here is actually written as 2 times x to the 1/2. So when we go to write the derivative, y prime equals, so now we take our negative 8 times our negative 3. 24x subtract 1 to the negative 9 power plus 2. Now I'm going to use this half power over here. This half power is going to come right down front to the x. Now 1/2 minus 1 is negative 1/2 power. So y prime equals 24x to the negative 9th plus 2 and 1/2 cancel out, x to the negative 1/2 power. Now, you may have a teacher or instructor or a book that tells you not to write anything with negative exponents. Do you remember what happens with negative exponents? They whisper to the guy in front of them. Do you know what they say? They say, hey you, flip over. Have you ever heard that before? So this is what it means. This negative is going to tell the guy in front of him to flip over. So you would rewrite this as 24 in your numerator, x over x to the 9th, plus 1 over, and now it's this 1/2, we can write it the square root of x. So that is how you would write that problem back in square root form and without negative exponents. Now let's try one with there's an exponent in the denominator. So I'm going to go ahead and rewrite this as x to the negative 3 plus I'm going to have this guy jump up to the top. So to do that, that's x to the negative 7. And this is still our y problem. So now to find the derivative, I'm going to bring those exponents down front, subtract an exponent. So negative 7 comes down here to the negative 8 power. And again, if you need to rewrite without negative exponents, that negative sign tells the guy in front of him, hey you, flip over. So he's going to flip over negative 7 over x to the 8th. And that would be your y prime, your derivative. Now we have a product problem. So we're going to go ahead and use the product rule, identify who f and g is, and write out the derivative so we can easily plug it into the equation. So here's my f guy, here's my g. I'm going to do my f prime is going to be 6x. My g prime is just going to be, I take this actually has an exponent of 1. 2 times 1 is just going to be 2. Ooh, I'm going to write that this is g prime though, so I don't forget. Now I'm going to write my equation. Y prime equals f prime g. I'm separating them out a little bit. This way, when I write them, I can write each piece underneath the equation, so it helps me remember where I'm at. So f prime is 6x times g, 2x minus 1 over 4, plus my f is 3x squared plus 6, and g prime is 2. Now I'm just going to go through and multiply everything out. So y prime equals, there I have 12x squared minus 6x over 4. I'm going to go through and reduce all at the end. Plus 6x squared plus 12. When you write your answer, you want to start with your highest exponent number first. So we've got a 12x squared and a 6x squared, so 18x squared minus, this reduces to 3/2 x plus 12. Here is your derivative. We have a fraction, which means we have our favorite rule, low-d high minus high-d low all over low-low. Are you ready? I'm going to identify f and g and their derivatives first. So here's my f piece, here's my g piece. I'm going to do their derivatives. F prime is just going to be 2. And g prime is going to be 1. They're making our lives real easy. I'm going to write out my equation. I need low d high minus high d low all over low low. So my low piece is my g, x plus 3. My high piece, the derivative of my high piece is 2, minus my high piece, 2x minus 1, needs to be in parentheses for sure, times the derivative of my low piece, which is 1, all over x plus 3 squared. Now I will go through and multiply out. 2x plus 6 minus, so this minus, this 1 really is going to drop away, but needs to be distributed through. So minus 2x plus 1 all over x plus 3 squared. So now maybe you're looking and seeing that your 2x and your minus 2x are going to go ahead and drop on out. So what we're left with is 7 over x plus 3 squared for your derivative. Again, from here you can go ahead and plug in any x value if you need to find the derivative at a specific point.